So yesterday I was playing Taco Ball when I saw the flag in the middle of the road and noticed it was at equilibrium because on both sides the same strain was being applied in opposite directions. And then I remember the same happens at the cellular level. Let's go from the beginning.
Here we have one of the most interesting cells, the neuron, and this is its cell membrane. Outside of the cell, we have the extracellular fluid, and inside we have the intracellular fluid. We also have channels through which ions can move from one fluid to another. And let's focus on two forces that influence the movement of these ions.
The first one is diffusion.
We have, for example, a potassium ion, which has a high concentration on the inside of the cell and a low concentration on the outside. So, the ion will move to the outside from high to low.
I'm going to try a parry and I want to add food coloring to water so drinking it is fine. I add some drops to each jar and these drops will spread gradually into the water. The food coloring particles will go from a high concentration to a low concentration.
And the second force
Is the electrostatic force.
which basically is the rule that opposite charges attract and like charges repel each other. We know that after diffusion, more and more potassium went to the outside, so it left behind a negative charge inside of the cell. And since potassium is a cation, which means positively charged, it is attracted to the negative charge.
So the balancing point between diffusion and electrostatic forces is what we call the equilibrium potential.
So the concentration gradient and the electrical gradient are equal but opposite.
And remember, equilibrium is a profound stance of all human activity.